Alright, so I'm here in the back of my house to talk about the slope of a line. The slope of a line measures how steeply slanted a line is. If it's slanted by a lot, it has a large slope. If it's slanted by a little bit, it has a small slope. So if you look in the back of me, you'll see two lines. Here's the roof of a shack in the back of my house, and there's the roof of my neighbor's house. Okay? And my neighbor's house roof is more slanted than my shack. So my neighbor's house roof has a larger slope than the roof of my shack. So in construction, people measure the slope of a roof by what they call the pitch. So the pitch of the roof is the slope of it. In the US, traditionally, the pitch of a roof has denominator 12. So it'll be something like 2 for every 12, 3 for every 12, 3.5 for every 12, etc. Because there are 12 inches to a foot. In algebra, of course, we don't care. We just calculate out to a number, and whatever that number is, it could be decimal, it could be a fraction, it could be a whole number. Whatever the number is, it is what it is. Now, when people are told to build a roof with a certain slope, okay, or a certain pitch, they would measure off. So let's say if they're told, build me a roof that is 2 to 12, okay, so they'll measure horizontally by 12 and they go up by 2, and that's the roof. Now what about a roof that's already there? How do people measure the pitch of a roof that's already there? Well, different people do it differently. And there are some professionals who do it with just shrinks, okay, and a plumb line that is a string with something heavy at the bottom. Or there's one way to do it, and I'll demonstrate that one way with a level and a framing square. A framing square has a perfect 90-degree angle, so if this one side of it is vertical, then the other side is horizontal. Or if I sit it over, then if one side is horizontal, then the other side is perfectly vertical. Whereas the level has little bubbles in it, so that I can, if I put it like this, and the bubble is in the middle, then I know I'm perfectly horizontal. So the level is perfectly horizontal, the phone is not. Okay? And then it has this other bubble down here that tells me that I'm perfectly vertical. So those are the two tools I'm using, and now I'm gonna measure it. Okay? So first I'm gonna measure the pitch of this slope. So real roofers can just measure off of the straight off of the shingle itself. I'm not a real roofer, I'm just a math teacher, so I'm gonna measure it off this flashing here on the side of the roof. So first I'm going to take my level and I will make sure it's perfectly vertical. So I put it against here and I make sure it's perfectly vertical. Okay. Now I have a vertical line. So it's like a y-axis. And I'm going to get my framing square and I'm going to flush it against the vertical line so that I end up with a horizontal line. So I'm gonna have to put down the phone for a second here so I can do that. Alright, so I have everything in place. You can see here that the level is vertical because the bubble is right in the middle, and the framing square is flush against the vertical line, so that makes the bottom of it perfectly horizontal. And if you actually look at that triangle, it looks exactly like how we would do it on paper when we compute the slope of a line. Alright, so let's take a look. The framing square is kind of old, so I don't know if you can see it, but it's 7 inches long, and whereas on the vertical side it looks like 1 5/8. Yeah, a little bit above 1 5/8, so let's just call it 1 5/8. So I have a figure here that's just like the XY configuration when I do a slope problem on paper, and has a rise of 1 5/8 and it has a run of 7. So the slope is 1 5/8 divided by 7. Yeah, plug in my calculator and I'll see what it's equal to. All right, so we have this picture. It has a rise and a run. This is the rise. This is the run. And this is the line we're computing the slope of. So the rise was 1 5/8. It was a little bit more than 1 5/8, but we called it 1 5/8. The run is the length of the framing square, and that was 7 inches. And the slope is equal to y1, so it's 1 5/8 divided by 7. So we're gonna pull out a calculator and we're gonna divide this out. So 1 5/8 is 1.625 divided by 7. And I get a slope that is 0.232, etc., rounded. Okay, so that's the slope. Now, if you're a US roofer, then you need your slope not as a decimal number, but you need it as a some number by 12. So, well, one way you could do it is to just solve this for 12. So x is equal to multiply both sides by 12. Then x is equal to 12 times 0.232. 0.232 dot, dot, dot. I'm gonna use the original number and then I end up with something like 2.7857, etc. So probably around 3 out of 12. But you know what? In real life, they don't do that. I mean, I got this weird thing because my framing square has a length of 7 inches. If you want to actually do it for a roof and you know ahead of time that you will need your denominator to be a 12, you would get one of the big framing square that's 12 inches long. They sell those. So anyway, that's the idea. The pitch is exactly the same as the slope and it is equal to the rise over run. And whatever that number comes out to be is the slope. All right, thanks for watching.